good people, Titus here for another Unreal Engine tutorial series, and today we're going to recreate the classic arcade game Asteroids. The game was originally released back in 1979 by Atari, and the main objective was to shoot and destroy the asteroids while avoiding collisions and laser fire by the alien saucers. Alright, let's not waste any time and jump right into it. Alright, let's set up our project folder. We're going to create a couple folders. I think the first one we'll call Textures. We'll do another one called Blender. And then we'll do another one called Levels. And then we'll do one last one called Blueprints. Alright, and I'm going to create a new empty level. So we'll choose the empty level template. So it's just kind of be dark here. And I think a good place to start is maybe with the SkyBox or the Sky Sphere. So for that, I have downloaded some textures to actually make the Sky Sphere. We're going to turn it into a cube map. In order to make a cube map, we need to orient or change these textures in a certain fashion, just so Unreal Engine can actually import them correctly. I'll bring on screen the orientation for Unreal Engine. So if you're working in some other software, you probably won't have to do this. But we're basically going to have to rotate just some of the images. When you're working with cube maps, if you're downloading from the web or you're creating them yourself, typically you'll have a a right, left, back, front, top, and bottom. These are going to make up the 6 sides of the cube. But this will make a little bit more sense when I kind of get into it here. So let me go ahead and we're going to start with the right image. So you can use any image editing software, so Paint, GNU, Photoshop, whatever you got. And then I'm just going to add all these images in a certain fashion. So the first one is right. The second one has to be the left or X negative. The third one has to be the back or the Z negative. Then next comes the front or Z positive. And then the next one is top or Y positive. Last one is Y negative or the bottom. And that completes our 6 images here. Now we're going to start with the right image. So I'm going to use the rotation tool. You can also click and hold if you're using GNU, and Shift R is your shortcut for the rotate tool. I have this image selected, so I can click and then hold Shift, and I just need to rotate it counterclockwise 90 degrees. I'll apply that. I'm going to go to the next image and rotate it clockwise 90 degrees. Hit rotate to confirm that. The back image needs to be rotated 180 degrees. Right there. Hit rotate to apply it. And then the front and the top are actually good, but the bottom image needs to be rotated 180 degrees as well. Oops, let me undo that. There we go, and rotate. Okay, so now I have all my images rotated correctly. I need to put them on a single image strip. Fortunately, GNU actually has a alignment tool, but I only have 3 alignment options. I have a left, center, and right, but I have 6 images. So I'm gonna have to do this basically in batches. So I'm gonna create a new image. My image was 2048 by 2048. So basically I need to take this number and times it by 3, which is going to be 6,144. I can then come over and select the first image, which is right, and I'll just copy that, and then I can right click and paste it in. Confirm the layer here. I'm going to go ahead and just delete the background layer so it's easier. Then I can select my alignment tool and select this image and just distribute left, and that one's good to go. The next one is the left image, so I copy that one. Then right click, edit, paste, confirm the layer. Then I'll select that layer, select the image, and distribute center. So it kind of lines up like that. Go back here, I'm going to select the back image next. Copy that one. Paste it over here. I'll confirm the layer down here. I'm going to select that layer, select the image, and hit distribute right. And this completes my first strip. So I can right click and merge down. So it's one layer, and that one's good to go. I'll create a new image of 6144, which is what we were using before. And we're going to do the remaining 3 images. So I'll select the next one, copy that, edit and paste, and confirm. And I will also get rid of the background. I'll distribute that one left. And the order of operations does matter, so otherwise your cube, when you actually create the cube map, it's going to be assembled incorrectly, and you're going to have weird distortions, so it's not going to look right. Distribute that one center. And last one here, copy this, paste it, confirm the layer. I can distribute right, that looks good, and then I can merge these down. Alright, so now I have my 2 strips. Now I can combine these into one strip. So we'll do File, New. We're just going to take 6144 times 2, which is 12,288. You may get a warning that your image is too big. You can just click OK, and it allows you to do it anyways. So I will simply right click, copy the first strip. More of the same, pasting, confirming the layer, deleting the background because I don't need it, selecting that strip and distributing to the left here. And then the last strip, I can copy that one, and then paste that over here, confirm the layer, select the image, and distribute it to the right. And now I can merge these layers down, so they're basically one image, or one strip, and that looks pretty good. So now we can export this. So we File, Export As. I'll select a location, and I'm going to call this my space strip. The export's going to take a while, so I'll go ahead and fast forward the vid here. Okay, our export completed, so we can go ahead and close out of GNU. We don't really need that here. Alright, and we can see our space strip right here. So it looks good. We now need to basically create the cube map. If you're working in Photoshop, there's a plugin you can get for free for the NVIDIA Texture Tools exporter. If you don't have Photoshop, the NVIDIA tool does have a standalone installer that you can use to make your cube maps. So it's free. There's also an AMD version of that, but I don't think it's supported anymore. So either tool will work though. So we can drag this into here. It'll move it in as an image as long as you did the format correctly. The texture type dropdown will give you an option for cube map. You can select that, and then you can browse around and make sure that the scene looks correct. If it does, let's change the format. Unreal Engine supports 32 BP unsigned BGRA. So this one right here. For the generate bitmaps, we can uncheck that because SkyBoxes typically only have one LOD anyways, or level of detail, so you don't really need to bitmap it. If you want to add some filters or effects, you certainly can. There's a lot of options there. But for this one, I'm just going to leave the rest the same. And then I'm going to save out this cube map as a DDS file. And we'll call it space cube map. Alright, so now we can come into our textures folder. And now I can bring in this texture. You can open it up and see how it looks. Should make sense. If you get any weird warping or it doesn't look right, or you get some weird like squares, means you have something rotated incorrectly. So you'll have to go back to the beginning of the vid and then see maybe where your rotation was off. And if it helps, this is basically what you're looking to do. So just imagine the arrows normally pointing up. So you're gonna have to rotate some of the images in a certain orientation and then combine them all correctly for Unreal Engine to read it. If you're working on anything else, I don't think you have to rotate them at all. I think it'll just work. But you can probably leave the settings the same. I'm gonna make some adjustments, but I don't think it's required or necessary. For the MIP gen settings, I'm gonna turn that to no MIP maps. I'm gonna set the group to be a SkyBox. And the compression I'm gonna set to a user interface. This should also be optional. I don't think that's gonna make much of a difference though. We can then right click on that import, create a material. We'll call it m_space SkyBox. Open this up. Texture samples require a UV or an X and Y. This has an X, Y, and Z. So we can delete that. It's not gonna work. We're gonna set the shading model to be unlit. And instead, let's search for a texture sample parameter cube. This one right here. I'm gonna call it what it is. Texture sample parameter cube. With that selected, we can search cube map. We have our space cube map right here. We can drag off the UV into a reflection vector world space. So this one right here. And just with that, we should be able to plug this in, and you can see your sky sphere starting to come together. Now we didn't set it in a coordinate position, so it kind of looks like a marble. It'll probably still work. So like if you zoom in, you can see how the sky sphere is actually going to act. So it still looks right. But generally, if you're working with some textures, they may not be as forgiving as this one is because it's space. So you may actually need to set the texture's coordinates to be 0, 0, 0. You can do that with a 3 constant input. So you just hold 3, click, and it'll give you this, and then you can just drag this into here, and you'll notice the shift is pretty dramatic. Like it looks like a perfect window now. So basically the texture's just kind of lining up correctly. So another setting you might want is there's a 2-sided option. You'll probably want to check that. I'm going to be importing a model from Blender that has the normals reversed. So if you don't have, or if you don't feel like doing that, and I'll maybe roll some B-roll footage that actually shows inverting normals on an actual static mesh. But if you don't want to do that, you just simply check 2-sided, and then it'll basically draw the image on both sides of your static mesh, so you won't have to worry about it. But if you are using one that's inverted, you can leave that alone and just use the static mesh that's correct for it. So let's go ahead and set that up now. So we'll come into the blueprints folder. We'll create a new blueprint class, be type actor. We'll call it BP_SkyBox. I'm going to come to my Blender folder. And then I had this little SkyBox cube. It's nothing special, it's just a cube. But I went ahead and inverted the normals on the static mesh. So it's basically inside out, or it's turned inside out. So when I open up my blueprint, when you do this, you can probably just hit add and add a cube. But because I have my own static mesh, I can just select that, hit add, and add my cube. And that's just gonna make things easier because the thing is basically inside out. So if you didn't do that, just remember to check 2-sided right here. First things first, we can go and select our material. You can load your material in here, and you can see it kind of looks pretty good. There's a few things you'll have to do for your SkyBox. some of it's probably pretty obvious. Collision, obviously we don't want any collision, so we'll set to no collision because you don't want the cube to basically push you around. And then you also want to turn off shadow, or cast shadow. The reason you want to do that is because when the light hits the outside of the cube, anything inside, including you or whatever object you have, they're going to be dark. So you don't want this to cast any shadows, you just want the lighting system to function without it. And then the next thing we'll do is I'm going to actually scale up on the X, Y, and Z. I'll just do something small, like maybe 100. So it'd be relatively small. And now, with that, we can take our blueprint, throw it in the scene, and then let's move it to 0, 0, 0. Oops. And then we'll save this as level 1. And then I'm actually going to go into the blueprints for our character. Now the default, I'm using the third person template, so it comes with the third person character template. We'll be changing that out later. But it has a movement component script on here. We can just set the gravity to 0, because we're actually not going to be dealing with gravity. And then if you hit play, you can kind of see how your SkyBox looks. You can see it lights up pretty good. We may end up adding a directional light later, but I think for right now, this looks okay. Now we can maybe add a little bit of special effects to our SkyBox, so maybe make the stars maybe glow. So let's go back to the material, and we're gonna drag this out a bit. To make this work, we need to be able to adjust these values through code. So in your textures folder, we can go to the material and add a material parameter collection. Call it npc_space. And for this, I'm going to add 2 scalar parameters. Set them each to a value of 1. The first one I'll do is a scene brightness. And the next one is a star brightness. I can then go into the material, drag my NPC in, Control D to duplicate that out. Now this particular image that I worked with, or that that we created, I'll just kind of show it, I guess. If we disconnect, we can see the different channels. So if I pull in the R channel, you can see that it kind of gets the stars and a little bit of the space. But if I look at the green channel, that one also has a little bit of space, and also the clouds or the dust. And then the blue channel is kind of more the same. So it kind of looks like it's kind of everywhere. So this one probably won't matter which one we pull into, but I'm just going to do the green channel. We'll drag into a 3-point levels. And we need to set a black value, a white value, and a middle value. So we'll need 3 constants. So we can hold 1, click on the graph 3 times. I think 0 for the black value is good. 1 for the white value is good. And then for the middle value, we can do something real small like 0.1 starting off. And now we need to come into a lerp node. So we're going to hold L, and that'll give us a lerp node when we click. And then we need a 3 constant, so we'll have 3, click on the graph. We'll drag this into A. We're going to drag the RGB into B. And then our alpha is going to be our scene brightness. So we can set our parameter name to be the scene brightness. Plug that into the alpha. And then we need to come into a multiply node. We'll bring that into the A channel. And then we're going to come into a final lerp. This will go into the B channel. This lerp will go into the A channel. And now we need to work on the alpha. This coming off, let's go ahead and set the parameter to be our star brightness. We're going to come into If you hold M, click on the graph, you can go into a multiply node. So we'll multiply the star brightness value against that. And then you can hook this into the first multiply and hook this into the alpha. And then hook this into the emissive, and you'll notice nothing has changed. Kind of looks the same. What we're basically doing is we're trying to get the white values, basically where we can keep the back of the image, basically everything but white, kind of the same. And then we can dull the white values and bring it back, and it'll kind of make the stars shine. We're also going to get the dust, because unfortunately this image doesn't have that masked out across the red, green, or blue channel, unfortunately. So if you find an image that maybe has that, this effect will work a little bit better. Or you could layer two separate images and do it that way too. But I think this will probably be okay for now. So we got this set up. You'll notice though, if we play the game, you know, nothing really changes, right? Kind of looks the same. So let's go into the SkyBox. We can go into the event graph, and we can add a timeline. And then we'll do play from start. And then we'll do a set scalar parameter value. This one right here. The collection we're going to be using is the MPC_space that we created. The parameter name we're messing with is the star brightness. And the parameter value, that's the one we're going to make here. So if we open the timeline, we're going to add a float track. We can call it param. And we're just going to add 3 values. So we'll add one that's 0, 0. We'll add one that's at time 5, 0. And then we'll add one in the middle. It's at 2.5 seconds. And I found that a value of 256 is really bright, and it gets the white to kind of flash on the screen. You may play around with these values to see what works for you though. And then if we scale this out, we kind of want this to interpolate a little bit smoother. So you can right click on each of the nodes and just hit auto. And then it'll kind of be a gradual thing. Then the other thing is I'd say autoplay set on, and then set it to loop. Compile and save that. And now you can hook up your parameter value into your parameter value here, and it'll update this scalar across these 5 seconds. You can also mess with the scene brightness if you want as well. But I'm just going to see what the star brightness does. And then there's kind of your effect. And it should kind of glow and flash. Maybe the scene brightness is too much, where it's kind of washing it out. Or maybe you're okay with it. I think it's a good starting point. Alright everyone, I think we'll cut it here to try to keep the video short, but in the next one we'll begin working on our movement code so we can get our ship flying around through space. But if you enjoyed the vid, please consider leaving a like and a sub to help grow the channel. As always, thanks for watching, and see you on the next one.